42 and 26 through 44. Let's go ahead and get started with numbers 11 through 18. The directions say to find the area of the blue and yellow regions. Now, number 11 just has a blue region, and so let's quickly take a look at how to solve this. So students, what we have here is a parallelogram that is, well, it's a parallelogram, so let's go ahead and turn it so it's so it's horizontal. That's easier to see. You don't have to do that, but it's easier to see. So there it is, guys. There's your entire base is 12. There's your entire height, 4. How do you find the area of a parallelogram? Base times height, 12 times 4, the answer is 48 square units. Number 12. Alright, now, number 12 here, we're going to find the area of this yellow part right here, okay? Now, I have to find, first of all, I know this side here is 6, and this side here is 6. So it is true that when you drop an altitude down, it will bisect this side. Now I can prove that very easily by just saying this. If I draw an altitude, then I know for sure there's a right angle here, okay? And if I have a right angle, then I have one side congruent to one side, and this side here congruent to this side. So I have an hypotenuse and a leg congruent to an hypotenuse and a leg in the other triangle. So these two triangles are congruent, okay? If I drop this altitude down, and if they're congruent, then I know these two sides here are congruent also. So if this is 3, then this has to be 3 also, okay? So in order for me to find the area of this triangle, I have to know the base and the height. Now I know the base already is 6, right? 3 plus 3, just find the height. Well guys, Pythagorean Theorem, come on. We have a right triangle right here, highlighted in red. I know the hypotenuse. I do not know the leg. I think for this entire video, I'm just going to do Pythagorean Theorem in my head, and I think it's time we've gotten there. I'm not saying that you should be able to do it in your head. I'm not saying that at all. Please feel free to not do it in your head, but I should not have to show you how to do it. You should know how to do it by now. So you're going to end up with 36 minus 9, 45. So this line right here, this height right here is going to be the square root of 45, all right? Now, the square root of 45 is the same thing as 9 times 5, right? 9 times 5 is 45. Cross off the 9, the square root of 9 is 3, put a 3 on the outside. So this entire height right here is 3 square root of 5. So I know what the base is, 6. I know what the height is, 3 square root of 5. So here we go, guys, pretty easy. 1/2 times 6 is 3. So now I have 3 times 3 square root of 5. Well, 3 times 3 square root of 5, you multiply outside number times outside number. So 3 times 3 is going to be 9 square root of 5. Okay, 9 square root of 5. And that is the area, and that would be, did I mess up somewhere? Let's see, 36 minus 9 would be 45. Let me check my work here real quick. Okay, I'm back. Wow, that was amazing math, wasn't it? How in the world could be 36 minus 9 be 45? That is truly amazing math skills. 27. So this would be 9 times 3. Cross off the 9, put a 3 on the outside. So 3 square root of 3. 3 square root of 3. 9 square root of 3. Very sorry about that, but I make those little mistakes all the time, to be honest with you. 9 square root of 3 square units. Okay. Alright, moving on to the next one. Let's find the area of this yellow figure. Now, first of all, students, understand, I should have made these bigger before I put these red lines. Well, I guess you guys are going to see the answers. That's just how it's going to be. Alright, here we go. Now, let's go ahead and find the area of this parallelogram. I know it's a parallelogram because this side is parallel to this side, and this side is parallel to this side, and it's a quadrilateral. So how do you find the area of a parallelogram? Base times height. Do I know either one of those two? Well, yes, I know the base. The base is 5. The only thing I'm missing is the height. Okay, but hold it. I have a right triangle right here, guys. Look at this. A right triangle. I'm missing a leg right here, and the leg is the height. So if I can find that leg, that's going to be the height. Now I know what the height is. Now I told you the last problem. I'm not going to work out Pythagorean Theorem for you. But in this case here, I could do it in my head. But in this case here, I think you need to see it in case there's any confusion on what to do with the square root. So one leg is 2. The other leg is x. and the hypotenuse is 2. Square root of 2, the entire thing squared. Now 2 squared is 4. X squared is x squared. Now here, be careful. You square the outside number, that's 4. You square the inside number, so you get this, okay? 2 times 2 is 4. 2 times 2 is 4, but hold it. I know the square root of 4. So really, instead of having 4 times the square root of 4, I have 4 times what? 2. Because the square root of 4 is 2. So now I have 8. So 4 plus x squared equals 8. Bring your 4 over, make it negative. X squared equals 4. Take the square root of both sides. X equals 2. So this height right here is now going to become 2. Okay? So I know the base of this parallelogram is 5, and I know the height is 2. So the entire area is going to be 10 square units. Alright? Alright, let's move on to number 14. Number 14. Okay, students, so on number 14, let's go ahead and get the answers out here so we can enlarge this thing, which I should have done already, but that's fine. Okay, now we're going to find the area of the blue and the yellow triangles, okay? Probably it's best to trace the blue triangle and start with it first, okay? So let's grab this and give some more space here. I'm not trying to cover up the answers, I'm trying to get more space, okay? So right now I'm going to highlight the blue triangle like that, okay? And let's see if we can't pull that off to the side. Hopefully we can do that. And slide that way over here like that. And then pull this up here. Alright. Okay, let's find the area of this blue triangle. Well, students, as I study this problem, I think it'd be easier to find the area of the yellow triangle first. Would it not? Here's your base. Here's your base. Here's your height. So the yellow triangle is going to be 6 because you have 1/2 times the base times the height. And that's going to give you 6. So that's easy enough. 6 square units. Okay, now let's move on to the black triangle or the blue triangle. In order to find the area of this blue triangle here, we have to know 2 things. We have to know the base and the height. I don't know either one of those. But hold it. I can find the base of this triangle. And you say, well, how can you do that, Mr. Earhart? Well, look, guys. This is a big right triangle right here. Correct? So let's say I use Pythagorean Theorem to find this whole length right here. And let's just pretend, just humor me, let's pretend the whole length down here is 11. Well, if the whole length is 11, and from here to here is 3, then we know from here to here is 8, which makes this 8, okay? So I'm going to look to find, first of all, the side of this really big right triangle, this side right here. So I have a leg of 4 right here. I don't know this whole leg here, so x squared, and my hypotenuse is 8. Well, you're going to end up with 64 minus 16, which would be 48. And then take the square root of both sides. You'll get the square root of 48, okay? So that's this entire side right here. So to be honest with you, I think the answer they want to give, they want to keep it in square roots. I just see no need for that when it's like this. So I'm going to go and take the square root of 48, and you're going to get 6.92, okay? So this entire length from here all the way to here is 6.92. That's the entire length. So I'm going to subtract 3 out of that. And when I subtract 3 out of it, I'm going to get 3.92. So the distance from here to right here is 3.92. So this distance down here is 3.92. Now, believe it or not, I already know the height. Earlier I said I didn't, but what I meant was it's not here in front of us, but the height of this blue triangle is the same thing as this line right here, the 4. I mean, think about it. It's a perpendicular line from the top of the blue triangle all the way down. So the height is 4. So I have 1/2 times 3.92 times 4. Okay? And what you're going to get is, hold on one second, let's see, minus 3 7.85. So I'm going to put 7.9. So the area of this triangle is 7.9 square units. Okay, hope that makes sense. Moving on to number 15. Alright, now, this probably will be a little more challenging. Let's see if we can figure it out, okay? There we go. Now, let's start off with, the, blue. Yeah, we'll start off with the blue, shaded area. Why not? So this 6 right here, students, please look. This 6 right here is for this length right here, in case you did not understand that. Alright? And this whole length all the way across is 9. So if the whole length all the way across is 9, and from here to here is 6, then from here to here is 3 more to give me a total of 9. So now I know this little length here is 3. And that means all these little lengths here would be 3. Okay? Every single one of these little lengths would be 3. Alright, so I know this length here is 3 right here. And I know this length here is 6. So I can very easily find this side of the square right here very easily by using Pythagorean Theorem. Notice it's an hypotenuse that I'm missing. One leg is 3, one leg is 6. So I can find this hypotenuse right here, and that'll give me the length of one side of the blue triangle. So if we did that correctly, it would be 9 plus 36, which is the square root of 45, okay? So this blue line here is the square root of 45. Now, obviously, all of these lengths are going to be the square root of 45. How do I know that? Because all of these right triangles are the same. So if I use Pythagorean's theorem on all of these right triangles, I would get the same thing out for the length of the blue side, the side of the blue square. So this side here is square root of 45. This side here is square root of 45. So square root of 45 times square root of 45 is 45. Square root of 45 times square root of 45 is 45. So the area of this blue square is going to be 45 square units. There we go. Now think about it, students. This is so easy. If I find the entire area of this big square and then subtract out 45, so this much here is gone, then I'm left over with the yellow shaded part. So the entire area of this whole big yellow and blue square is going to be 81. 9 times 9, length times width. So the entire area is 81. Now subtract out the blue area, and what you're left over with has to be the yellow area, which is 36. Okay? So 45 square units for the blue, 36 square units for the yellow. Alright, moving on to number 16. Alright, now, let's see if we can't do some labeling here, okay? First of all, I would like to point out to you the blue shape is a parallelogram. Do you see that right there? It is a parallelogram, okay? So I'm going to take that parallelogram and pull it off to the side. Give me a second to do that. Let's pull it over here. Okay, now, how do I know it's a parallelogram? Well, I will show you. Hold on one second. The reason is pretty simple. Before I get to that reason, though, I want you to know a lot of you on a test or a quiz could probably figure out that you have a parallelogram, which I'm trying to show you right now, just by looking at it. And I get that, but I always want to show you why, okay? We learned many weeks ago that when you have a triangle, and this is an equilateral triangle, all 3 sides are congruent, so we know this is 10. So if this is 10, and from here to here is 5, then that's a midpoint, okay? Now if that's a midpoint, that makes this 5, okay? Which, if this angle here is the same as this angle here, you're going to end up with another equilateral triangle here, okay? So if this is truly the 5 right here, this is the midpoint. What we've learned in the past is whenever the mid segment is drawn, it connects the midpoint of one side to the midpoint of another side, then you have this length here will always be half the length of the side it's parallel to. So what I do know for sure is I've got 5 here, 5 here, 5 here. All of these are going to be equal 5, that's going to be a 5, this will be a 5, etc. Okay, so what I have is a parallelogram with a length of 5 and also a length of 5 here and a length of 5 here. So I've got my base is 5. The only thing I'm missing is the height, or this right here. Well, students, I've got a right triangle right here. Look, guys, I've got a right triangle, and they're telling you this length right here is 2.5 from here to here, and you know the hypotenuse is 5. So using Pythagorean's theorem to find this missing leg right here, I'm highlighting in green, you would have the hypotenuse squared, 25, minus the leg squared, 2.5 squared, 18.75. And you're going to get 4.33 for this dotted line right here, 4.3. Okay, that's the height. So the height of this parallelogram is 4.3. So I have a base of 5, a height of 4.3. So 4.3 times 5 would be 21.5. So the area of this blue parallelogram is going to be 21.5. Okay, now if this yellow triangle is equilateral, which it is, and this triangle is equilateral, which it is, then I know that if I drop an altitude down, it's going to divide this side in half. So I know this side here is 2.5. Well, students, we just found this length right here, this height, by using a right triangle. Look, guys, we just had a right triangle right here. It had a hypotenuse of 5 and a leg of 2.5. It had an hypotenuse of 5 and a base of 2.5. So with that in mind, we've got the same thing here. We have a hypotenuse of 5 and a leg of 2.5. Okay, so we can definitely then find the length of this height will be the same thing as the height of your parallelogram, 4.3. So the height of this triangle is 4.3. The base would be 5 all the way across. So how do you find the area of this yellow triangle? 1/2 times base times height. 1/2 times 5 times the height is 4.3. And so the answer would be 10.75, approximately 10.75. So if the area of this yellow triangle here is 10.75, then the area of this yellow triangle here is 10.75. So I have 10.75 plus 10.75, which is going to give me 21.5. So the area of the yellow triangles together is 21.5 square units, which ends up being the exact same thing as this blue shape right here. In other words, these two yellow triangles would fit right inside of this blue parallelogram. This triangle right here would fit right here, and this triangle right here would fit right up here. So the two areas are identical. Okay, all right, moving on to number 17. Let's see what we got here.